reading where you're going with this. This is not going to be a style that I would have you guys do as a fill in the blank. Algebra proofs, I like to just give you guys, and you just read out all your steps and stuff like you have in the past. Here, it's a little bit weird because they skipped some things. What I was hoping that you guys were just going to be able to notice is what happened. What properties were there? Okay. So why did you write that down? Just given. Okay. I know it's on the other side. Whatever. What happened between here and here? What did they do? Yeah. So they subtracted over. So it was just subtract property equal. Obviously, we would have then done a simplify step. We would have written it and then done a simplify step. Where did they go from the next one? Yeah, another subtraction property. It's not solved. What did they do to get from 2x equals negative 20 to... Yeah. Yes, sir.
So what if you, so like if you're on like, and you don't use simplify, is it wrong?
Yeah. This one was, it was more like what was the step that happened? When I give you guys things like this for the algebra ones, I'm going to ask that you do them just like we have been. So when we do our quiz later on this week, I think it's, what, Friday? Still think it's Friday. No, we might be able to go Thursday, to be honest with you. But we'll play that one by ear. When we get going, I always want you to kind of go step by step by step by step. Okay. The next one was the bottom of the second page, correct? Okay. step 3, there's actually 2 steps that are going on. I don't know if you caught it. There should be two segment additions here. If I have you guys do this again, I'll make sure that every line isn't like combined with one statement, like one reason. I'll make sure everything's split up line by line by line by line. So look at what we have to start with. We start with wy is congruent to xz, and then you want to prove that wx is congruent to yz. So if you look at your diagrams before you get going into all of the stuff, they're talking about wy and xz being the same thing. You okay with that? If you look at those two segments, what do both of those segments have in common? xy, very good. They both have xy in common. So in the back of your mind, you know that you can say that wy is made up of wx and xy. Xz is made up of xy and yz. If we're able to say that those two guys are equal to each other, we can cross out what the overlap is. That's the idea that when we start getting into proofs of what you should be looking for. Okay. So first thing first, we had our given wy congruent xz. Why did they switch it to equals, you think? Oh, but why do you think they have to switch it to equals? Yeah, basically the next step. For any of the math properties that we know, segment addition, things like that, you have to be in equals. Doesn't work otherwise. So the next one, you're using segment addition twice. And if you had seen that written twice, you probably would have picked up on it a little bit easier, which basically means that I know that wy is made up of what two smaller segments? There you go. I know that wy is made up of wx and xy. I know that xz is made up of xy and yz. Now, aren't those two things equal to the same thing? And when those two things are equal to the same things that are equal, those things have to also be equal. So you can substitute in to do that. Honestly, guys, all the proofs that you're doing, whether they're going to be segments or angles, they all kind of have the same steps. Segment addition, substitution, angle addition, substitution, subtraction, congruency flips. It's really all they are. So what did they subtract out from both sides then? xy, so what are you left with? And then, what do you think they did? Bless you, what do you think they did at the end? Okay. Excuse me. And then lastly, this last one is really fast. What does the segment bisector do? Bisects the segment. So, according to your progression sheet, when you have a segment bisector, what did it say to do next? State the segments that are congruent. So, if AT bisects MH, according to our diagram, that means MT and TH have to be equal. Now, do I need to go equal or congruent with this one, do you think? congruent. I'm not saying congruent because everything else is written in congruent, and it doesn't look like we can do any math. You can't just say definition of a bisector, because a bisector, you don't know what was bisected. You have to say that it was a segment bisector. Or when we talk about angle bisectors here in a little bit, you have to say it's an angle bisector. You have to denote which type of bisector. So have I used up all that first given statement? Yeah. Go to the next one. Next one says AT is congruent to TH. Do I have two things that are set equal to the same thing? Remember, whenever you have multiple givens, you use them until you can't use them anymore. You go see how in the first one bisects, there's a progression you can do. This one there isn't. If you put those two out of order, it's not the end of the world, but I'm just trying to get you guys in the habit of whenever you have a given statement, if it has a definition or a progression with it, use it right away so you don't forget it. And then go to the next given statement. If you have them flipped, it's not the end of the world. You still have, it's still a correct proof. It's just I'm trying to make sure to maintain that sequence of thought. Now, again, like I was saying, do we have two things that are set equal to the same thing? Yeah, they both equal TH, which means they have to be what to each other? Yeah, they have to be equal. Put something in for something else. What are you using? Substitution. That's the complexity of the things that I want us to be able to do. I'm not trying to be fancy. I'm not trying to be overly crazy or anything like that. Which means now we get to do stuff like this. Today, unfortunately, is one of those days of progressions that we kind of have to write out about 4 or 5 of them. It's not that bad. We're going to be basically looking at angles and angle pair relationship things for progressions today. We have plenty of space for everything we're going to need to use. What's that? Don't remember. So, first thing I want to do is let's do if given complementary. If given complementary angles. Do you guys remember what complementary angles did? Perfect. So what do you think we're going to state? So if you're given complementary angles, we're going to state angle plus angle equals 90. I'm leaving it really generic with that idea of just angle plus angle, just like we do with segments. Segment plus segment is something else. We don't know what the angle letters are. Depends on the problem. Okay. For example, if we're given angle 1, angle 2 are complementary. We're given that angles 1 and angle 2 are complementary with a little picture or whatnot. Why don't you just be words? As you go to start setting this stuff up and writing the things out, same idea. You'd state your given, angle 1 and angle 2 are complementary. That was given. So what two angles then have to add up to equal 90? Angle 1 plus angle 2 has to equal 90. Obviously, you might have more letters, you might have something else, but this is the basic of it. Angle 1 plus angle 2 equals 90. What do you think the reason is? Definition of what? Complementary. Like literally that. Yeah. So, what do you think will happen if you have supplementary? Same thing with supplementary, right? Well, what does supplementary add up to? No, he was halfway there. He was working twice as hard. I'm not very good at math. Okay. We good on this one? I don't want to get too far ahead of everybody. All right, try another one. To complement or supplementary. If given supplementary. I didn't forget you, I just couldn't remember if I had it. And because I couldn't find my duct tape. You just don't know what you're going to get from me some days, do you? Well, I probably have duct tape lying around somewhere. So if you're given that you have supplementary angles, guess what you're going to state? Two angles, right? Angle plus angle has to equal. Right. Okay. Again, we're just using the definition of what supplementary means. Supplementary means that two angles add up to 180 degrees. So another example. No, if you're given supplementary angles, what you want to do is you're going to state angle plus angle is 180. We don't know where it's going to get us to. It depends on the style of the problem. The proof statement is something given to you separately every time. So if we do this and I'm just going to cheat with single letters and just call this angle A and angle B. And I say angle A and angle B are supplementary. Your statements and reasons would be very, very easy. Angle A and angle B are supplementary. Given. Well, according to the sheet that we just wrote down, I would then say angle A plus angle B has to add up to equal. And what definition do you think we're using now? Have you noticed the pattern with this stuff as you go through your progression sheet? We're using the midpoint, definition of midpoint, bisector, definition of second fixed. What's that? Yep. And this is how we keep it straight. This is how you keep all the order of everything you're working on a sheet of paper, so that way you know where to look. How do you figure it out? And that's why I do these things. Not too terrible? Okay. Let's do another one very similar to that. If, guys, given a linear pair. If you're given a linear pair. Linear pairs add up to equal how much? 180. So, what do you think I'm going to state? Exact same. If you want, that's fine. But sometimes people do that, they don't find it. That's why I'm saying if you that way you see if given linear pair, go to that one. I'm going to state angle plus angle is 180. Three and four are linear pair. Three and four are a linear pair. That means angle 3 plus angle 4 has to equal 180. And remember, you don't know a lot about this stuff yet. The only stuff you know with working with proofs is angle addition, segment addition, substitutions, subtractions, things like that. And as you go along with this stuff, if you're given something as a linear pair, you know you can write an equation. You know you can get something equal to 180. If you have something that's supplementary, you know you can add something equal to 180. You know, if you have two angles that are both equal to 180, those sets of angles have to be equal to each other. Things like that. There's not a lot going on yet. Okay. When we get to triangle stuff, then it starts to open up a little bit more. Okay. We start to do a few more things. Sorry, I something like that. All right. We're almost done. What's that? Yes. Yeah. In this case, let's say we're given that you have right angles. What do you know about right angles? Do they always equal 90? Okay. So if angles that have the same measurement, they're always what to each other? They're congruent. So if we're given right angles, then what we're going to do is we're going to state right angle congruent to the other right angle. Yeah, right angle. Okay. For example, I'm just using numbers that we don't have to use so many letters for right now. Angles 1 and 2 are right angles. That's something you might be getting. You might be shown right off the bat that you've got two right angles. Okay. Well, you know if you got right angles, then say something about it. If 1 and 2 are right angles, what's the relationship then between angle 1 and angle 2? They're correct, but what are we stating here? Congruent. Quite literally just filling this in with the same thing we just wrote. And here's where it's not a definition in this case. This time our reason is all right angles congruent. Whenever you have two right angles, and you have to say that they're congruent to each other, your reason will always be all right angles congruent. I know it's a lot. You seem very, very, excited today. Good times. Yes, no. Nobody cares. I do. Patiently waiting. Patiently waiting. Patiently waiting. I think I got one. I think I've got one more. I know I have at least one. I know it's the worst. I thought you were complaining. I'm like, you'll be fine. All right, I think this is our last one. And I just got to double check my notes. One of the times that when they have given stuff with proofs, sometimes they like to give you something that you have to do more than one step with. For example, if you're given perpendicular, if you're given things that are perpendicular, you have to do 2 steps. There are 2 steps. If you're given perpendicular, first thing you do is state the right angles that are formed. And then the right angle congruent to the right angle. You have to say that you have right angles before you can say that right angles are congruent. It's basically what this is getting at. Because you guys all agree that when you're perpendicular, you create right angles. Once you say that you have right angles, then you know that right angles are congruent. Okay? So the way that this works, I know there's not a lot of space on this square for me to show you what the reasons are for both of those, but if I do an example, these are the reasons you'll always use for this stuff. So let's say we have let's see, A, B, C, we'll call this X. Let's say XB is perpendicular to AC at point B. We'll use this as our example. Excuse me. Now, if I go right to the diagram, that means where those 2 segments are perpendicular to one another at that vertex, you get right angles. Well, in this diagram, how many right angles do I get to draw in? 2. There's just 2 of them. Okay. So if I'm looking ahead before I start writing all this stuff out, I know that I got a right angle here and a right angle there. I know that's going to happen. Okay. So here's what it looks like when you start putting this together in a proof when you have perpendicular. XB perpendicular to AC at point B. Sometimes it tells you where it's perpendicular, sometimes it doesn't. If this just said XB is perpendicular to AC and it gave you the diagram, you could go ahead and say from the diagram you know that that's where those angles have to occur. if that's your given. From there, I would say my two angles that are created. The two angles that are created are angle ABX and angle CBX are right angles. You have to say what the angles are. You have to say what the angles are before you can say that they're congruent. When you have angles, you have to use 3 letters when there's a common vertex involved, as opposed to saying angle 1 and 2 or angle B. I can't say angle B here, because there's a common vertex. Now, the reason why I can say that is, what definition did I just use from going from perpendicular to saying I have right angles, do you think? Yeah. Usually whatever you have here is the definition you're using here. 99% of the time. Okay. So now you have right angles. So think about the progression we just did. If you have right angles, then what do you know about the two right angles? They're congruent because what's the reason? What's the reason on your sheet? Very good. So now then you would say angle ABX is congruent to angle CBX because all right angles are congruent. That's how this stuff works. As you go through progressions, you might have to use one in conjunction with another. Perpendicular is one of those examples where you have to tie two together. You say that you've got right angles, and then we know that right angles are congruent. I think my sheet of paper that I had my example on there accidentally threw out. Let me just pull it up. there's one that says 2.7 Geo old book. It's fine. From the old textbook. Like 2 textbooks ago. I want you to do these 2 prompts here. 1 and 2. They're fill in the blank. Pull it up on the calendar now. Screenshot it so you have it so you don't lose it. But just write them out on a sheet of paper. Oh, you can pull it up. You got a lot more. There's more to the boundary. You're not going to fit all in one. You'll have to just actually pull it up on the calendar. I know it's so hard. You only had Chromebooks that would pull things up on the internet. Yeah. All right. I didn't print it because I just figured it was just I wanted you guys to write it. It's easier to see as you write it out. You get the feel of what is going on. So fill in the blank ones are nice, but the more you write it as you're doing it, the easier it becomes. Okay, so do those 2 for me for tonight, and we'll go on for there for tomorrow. Okay? Oh, you can keep it. In case you need one tomorrow. I hope you don't need one tomorrow.